Okay, Richard here again from WYOY Webcast. Yes, this is the first video explaining the universe and whatnot. So I'm going to start right off the bat with gravity. For a long time, people have the premise, or the saying was, we're always talking in terms of the pull of gravity, but gravity in and itself has always been this mysterious thing to scientists. And, excuse me, and when you start to think about it from a molecular point of view, and you start to understand, well, if you take our basic concept of the atom, is you've got a neutral center made of neutrons and positrons, and then you've got electrons, which are negative charge that spin around it, okay? I'm not sure that's really the best picture to make of an atom, but for now that's the model we go with. So the point there is that somehow it's a play of magnets, if you will, the positive and the negative positrons and electrons, and somehow they pull other atoms together, they hold them in place, and our premise for gravity being a pull effect is kind of based on that. I believe so, okay? Regardless, I'm here to say to you today, my biggest illumination is that gravity is a push effect. Now, the theory was first introduced by two French mathematicians back in the 1700s. Okay? Look it up. They're on Wikipedia. Okay? And they talk about it. So just Google, do a Google search for push effect of gravity, and it'll come up. Okay? Anyways, so to conceptually explain this to you, imagine a bowl of water in front of you. Now look at the water in your mind. So let's take this bowl of water, let's take this two-dimensional representation and we'll put it in between us, okay? Here's you using your imagination. So if I go to the center of the bowl and I tap the surface of the water, I get a wave that goes out in every direction, right? Go try it for yourself, and I know you've probably done it. As a child, I don't know, I played with water. And when you tap, the waves go out, they hit the edges of the water, and they bounce back to the center, okay? If I tap off-center, I still get the same effect, where the wave goes out, it hits the edge of the bowl, and comes back to the point of origin, okay? Now, understand that everything, and I mean everything in the universe, throws off energy. I'm throwing off energy right now. Chemical reactions going on in my body, heat, light bouncing off of me, so it's not coming necessarily from me, but I have light hitting me, bouncing to you, which is how you can see me. So there's energy coming from me right now. There's energy coming from everything in this room right now. There's energy coming from this planet, the sun, galaxy, asteroids, whatever you can think of, there's energy radiating out from it. So now if you go back to the pool of water, or the surface of water, now imagine anything that you want, everything in the universe, and just tap the water in different strengths, in different speeds, frequencies, okay, rates of speed, okay, which is what a frequency is. And a star would have a big splash, a human being like me would have just a little splash, but everything has, like, take it as a tap, and you've got energy emanating from it, bouncing on the walls of the bowl and coming back to the center, okay? For any tap you have, so everything in the universe, you can create a tap on the surface of the water representing it, whatever it is that you think of in your mind. So you can imagine now, so say you could put 100,000 million fingers and tapping the surface of the water kind of everywhere, you'd have energy, waves of energy going in every direction, hitting the side of the wall, coming back to its source, and because they're wave energy, they're intercrossing, they're all the different things causing waves, all the waves are intercrossing each other, okay, right? So if you want to simplify the example, just go back to your bowl of water and tap on 2 points at the same time, And you'll see that the waves will still happen, hit the wall, come back to the source, to wherever your tap was, but as they cross the other waves, they're kind of just crisscrossing each other, and one has a bit of an effect on the other wave, but not much. The momentum of one wave carries it in one direction, momentum of the other waves sends it along its way, and they pretty much do their business as if it was one singular wave only. Okay? Well, that's the secret to gravity. Everything throws off energy all the time. Okay? Now, let's take, instead of two dots on the water, remove the bowl of water for a minute. Now let's just put two objects together, or not together, but two objects in space side by side. For now, let's keep it simple. These are two very simple rocks. They're both made of iron, nothing else, just iron, okay? Let's keep this example simple. So they're sitting there, now they're throwing off their own energy, yes, but at the same time, there's energy from everything else in the universe coming at it from every direction, right? Because when you think the surface of the water example, three-dimensionalize that, okay, make it 3 dimensions, then the energy is going in every direction as a sphere, out, hitting the edges and coming back to its source, okay, eventually. So everything is throwing off energy everywhere. So now think of these two rocks. There's all that energy in waveform coming from everything else in the universe, and you know how when I said in the water you say you could go 1,000 times and you have a lot of crisscrossing going on? If you've got enough crisscrossing going on, the surface of the water will actually look calm. But underneath, you know you've got waves crisscrossing. Kind of explains what space looks like. It looks calm, but you've got energy crisscrossing in every direction all the time. Okay? Now science calls that the ether. And when if you go back to that, those two French mathematicians who were talking about gravity being a push effect, part of their problem that they had in proving their theory is they couldn't prove the existence of the ether. Well, in 1999, I believe it was, they did an experiment up in the space shuttle, and long story short, it actually proved the existence of the ether. Okay, so I'll talk about that in a minute. Okay, so now, let's go back to our two rocks. So just accept my premise for now, there's energy coming at it from every direction. So if I look at this single rock, I've got energy here, 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 on all sides, and it's pretty much even energy because all the energy of the universe kind of averages itself out. So you've got a pretty much even pressure of energy coming on every side. Okay? This object over here, same thing. Now, but what's happening is depending on the frequency of the energies coming towards the object, most of the energies will simply go through because it's wave energy, and you've got to kind of accept that an object, for the most part, is wave energy, okay? And I'll explain that a little bit, and I think nowadays even scientists admit that even a solid object is still mostly empty space. What keeps it together is the magnetism, if you will, which it kind of alludes to gravity and this and that. They're not sure, but they're all agreeing now more and more every day that even a solid object is still mostly empty space. Okay? So with that idea in mind, the energy's coming at it, most of it will go just straight through. Won't affect it at all. However, depending on the frequency, the amplitude, not the angle, but well, actually the angle too, some of that energy coming from everywhere in space will be absorbed by the object. If it's at the right frequency of whatever the atoms inside of it are spinning at, it might actually fall in sync, and then it'll help the spin continue spinning. Kind of like when you take a top, right, and you just tap it on the outside, you can keep its spin going. That's what's happening to every object right now, including you and I right now, okay, in part. So some of it's absorbed and it becomes part of the spin, and then if it's out of whack a little bit, well, that excess energy which might occur gets thrown back out. Thus the energy coming out of this thing, this object, okay, like everything else in the universe. Excuse me, I'm actually running out of breath. This stuff, I know you might go, oh, God. It actually excites me because when I know this premise is correct, and I find it exciting to understand something in such a fundamental level. Okay. Anyway, bear with me, and you'll know you're going to go, oh, that actually makes sense. Anyways, some of the energy is deflected. Some of it is deflected in full. So the light, for example, which allows you to see this object, that's one example of a full deflection. A partial, or reflection I should say, a partial reflection could be based on the color in a sense, because you've got white light hitting it. Some of the light is being reflected back, not all of it, which is why we see different colors. Okay? Again, science-based. In my day, this was more or less 10th grade physics. Okay? Anyways, so you can find this out for yourself, or you can know that what I'm saying is true from that premise for your own research. Okay, so now some of the energy goes straight through, some of it is absorbed, some of it is reflected or deflected. It's not a full reflection. Sometimes it might just be deflected in another direction, which is what actually we call refraction. When you put your hand in water as an example, okay, and you look at it, you know it might be a foot deep in water, but it looks like it's only 3 inches deep. That's caused by refraction. So that means the energy, the light energy, is being deflected, which is another way of saying partially reflected, not completely. Anyways, okay, I'm kind of loosey-goosey on those terms, but the whole concept of refraction is just that. The energy is deflected. It's not totally blocked. It's not totally getting through. It just kind of is made to change direction a little bit. And that is what causes refraction. So refraction happens not only for light, but any energy frequency. Okay? So anyways, so again, now I'm going to reiterate. Energy coming in all directions. Most of it going straight through. Some of it being absorbed. Some of it being deflected, refracted, reflected. Okay? All right. On all sides. Pretty much on an even keel, an even basis. Now I take this object here now. Well, it's doing the same thing. So if I bring these two objects closer together, well, it's safe to assume that the energy coming from this direction, that is being either blocked, absorbed, reflected, deflected, refracted here, isn't hitting here, because it's standing in its way. Same thing can also be true of the energy coming this way, that's being blocked, refracted, deflected, whatever, absorbed, okay, is not reaching this side here. So that means that because as they get closer together, there's less energy push on this side than there is on this side. And the same thing is true here. There's less energy, universal energy push here than there is on this side. Thus you have gravity, because you got more push here than here, more push here than here. And even though the objects itself, they are creating some push, it still does not equal to the push coming from the universe on this side. Okay? And there's your theory of gravity. That's it in a nutshell. Now, this is where I pretty much end the video. I want you to think about that and look it up, do some of your own research, the push effect of gravity, and you'll see the theories out there, and for some reason it's not talked about much. Now in my next video, I'm going to elaborate on the different permutations, not permutations, but what does it mean, the fact that gravity is a push effect? How does that change our understanding of the universe? Okay, so I'm going to start on that in the next video. Talk to you later. See you in a bit. Bye for now.